Alright, Math 1, you should have worked on some of these problems already, so we'll do some and then you can have some time to work on some more. So, we're going to solve these by graphing. So if we look at the first one, they're in slope-intercept form. You can do these ones by hand easily. So start at negative 4, slope of 3 over 4, so we go up 3, to the right 4 for our next point. Okay, then draw our line. Now we're going to graph the second one on the same, so a positive 4, and then a negative 5, 4 for our slope, so we're going to go down 5 to the right 4. So we can easily see where they intersect. And that's our answer, right? That point where they intersect, which was negative 1, 4, negative 1. So that's the solution to both of these equations. That's where they're the same, and because there's one solution, we write down the solution, and it's that consistent independent is another way of talking about it. Okay, let's look at number 2 now. So we start out with a positive 2. A slope of negative 2 is like negative 2 over 1. So we go down 2 to the right 1. Or we could go up 2 to the left 1. Then the second equation, we start at negative 3. Another slope of negative 2 over 1, which that should tell us right off the bat these guys are going to be parallel because they have the same slope. So when they have the same slope but different y-intercepts, they end up being parallel, which means no solution or inconsistent. Okay, because they are those parallel lines. So there's two. We can have one solution, that consistent independent, inconsistent, which is no solution. Okay, or sometimes we have another one. Okay, so let's start off negative 2, slope of negative 1/2. So I go down 1 to the right 2. Or doing that same pattern, we could go up 1 to the left 2. Okay, then the second one, positive 2, slope of negative 3 over 2. So down 3 to the right 2. So go down to the right 2. So down 3 to the right 2, down 3 to the right 2. So you can see where they would intersect, which is right there at that point, because I'm not very good at drawing straight lines. So it would be 4, negative 4. So another consistent, independent, one solution. And so we give that solution. Okay, number 4, we have a plus 2, and then 1 over 4, so we go up 1 to the right 4, right? So from that point, up 1 to the right 4. Or the opposite, down 1 to the left 4. Okay, and we start at a negative 2, and it's a negative 3 over 4, so we go down 3 to the right 4. So we end up right here, or up 3 to the left 4. So we can see where they're going to intersect here, which is this point right here of negative 4, positive 1. So again, consistent, independent. Alright? Okay, so we've got some more, still some more in slope-intercept form, so let's keep doing these. Alright, so start at negative 4, slope of 5 over 4, so we go up 5 to the right 4. Draw my line, start at positive 2, and we go down 1 to the right 4. Or up 1 to the left 4. We can see where those ones intersect as well. So it's at 0.41. Consistent, independent. Okay, looking at 6, start at negative 2. Slope of down 5 to the right 1. Or to the right 3, so it'd be like clear down there. Or up 5 to the left 3. Okay. Then a positive 2 and a slope of down 1 to the right 3, or up 1 to the left 3, and we see where they intersect. So that point right there, which was -3, +3, so consistent, independent. Alright, now let's look at number 7. So a +4, okay, slope of -5, that's like -5/1, so I go down 5 to the right 1. And then the second equation, start at -3, slope of 2, which is like 2/1, so up 2 to the right 1. We can see where they're going to intersect, can't we? A +1, -1. So another consistent, independent. Alright, now looking at number 8, start at -3, slope of -5/3, down 5 to the right 3, or up 5 to the left 3. Okay. Second one, start at +3, and we have the same slope. Down 5 to the right 3, so that should tell us right off the bat these guys are parallel, so there's no solution, so it's inconsistent. Okay? So, now take some time and try to do the next problems on your own first, and then we can watch this, okay? Alright, so hopefully you had a chance to attack some of these problems here. And let's see what we've got going on. Okay, so we start with the first one, -3. Go down to -3, 2/1, so up 2 to the right 1. So we keep following that pattern. We're down 2 to the left 1, same pattern. There's our first line. Okay, then for the second one, we're going to have to solve this one for y, aren't we? Okay, now if we had graphing technology or Desmos, you could just type it in like that and see what it is, but if not, we add 4x to both sides, giving us 2y equals 4x minus 6. Divide by 2 on everything, and we get y equals 2x minus 3. Okay, so start at -3, same slope. So what do we see? Okay, same exact line. So they overlap, so there's infinitely many solutions here. Okay, this is the consistent dependent. So we have an example of all the three types. When you have one answer, looks like this. You write your answer as a point. When they're parallel, there's no answer, no solution. If it's the same line, infinitely many solutions. Okay? So, consistent dependent, consistent independent, inconsistent. Alright, let's take a look at the next one. So, x minus y equals 2. So we solve for y. Negative y equals negative x plus 2. Divide by -1. We have positive y equals positive x minus 2. So go down to -2. That's like 1x, so it's like 1/1. So up 1 to the right 1. Or down 1 to the left 1. Okay, then the second problem, same idea. 5x minus y equals 2. Subtract 5x. Negative y equals negative 5x plus 2. Divide by -1 to get that y to be a positive. Y equals positive 5x minus 2. So it starts at the same place, but now we're going up 5 to the right 1. Okay, we see that where they intersect is actually the y-intercept. So 0, -2 is the solution. Alright, so let's just keep going. So you should have tried most, if not all of these. If you haven't got to some to be able to try it, then just let's pause it and do that. Alright, so we start by simplifying. So we'd subtract an x from both sides. So we get y equals negative x plus 1. Go up to positive 1. It's like negative 1 over 1. So down 1 to the right 1. For the next one, we'd subtract an x. We'd get negative 2y equals negative x minus 8. Divide by negative 2. We get y equals a positive 1/2 x, because x over 2 is like 1/2, plus 4. So go up to plus 4. Then we go up 1 to the right 2, or down 1 to the left 2. And we can see where they intersect. To this point right here. So negative 2, 3 is our solution there. Okay, on number 12, subtract a 3x from both sides. Negative 2y equals negative 3x minus 4. Divide by negative 2. Get y equals positive 3/2 x plus 2. Okay, change this one, subtract a 3x. And we'd end up with negative 2y equals negative 3x plus 8. Divide by negative 2. We get y equals positive 3/2 x minus 4. Okay, now we should notice here, because I did them both at the same time, same slopes. Okay, so it would look like this, and it would look like the same thing right here. But because they have the same slopes, I know right off the bat it's going to be no solution. So I honestly don't even need to, if I change them both to slope-intercept form, I don't really even need to double check them. Okay, number 13. Subtract an x from both sides. 4y equals negative x plus 16. Divide by 4. Y equals negative 1/4 x plus 4. So up to positive 4. Down 1 to the right 4, or up 1 to the left 4. Now you can graph right after you do the first one, or you can wait and solve your second one, because sometimes, like we saw last time, you get the same thing. Okay, divide by negative 2. Y equals positive 1/2 x plus 1. So up 1 to the right 2, up 1 to the right 2. This is a single answer at 4, 3. Okay, 14. Subtract an x from both sides. Get 3y equals negative x minus 9. Divide by 3. We get y equals negative 1/3 x minus 3. So down to negative 3. Down 1 to the right 3. Or up 1 to the left 3. Okay, now the second one, notice it doesn't have the x and y on the same side. Well, it does, but it also has the regular number. So we just need to get the y by itself. So I could subtract a y, and I'd have negative y equals negative 4 minus 2x, which I could rewrite as negative 2x minus 4. But then I just divide everything by a negative 1, and we get y equals positive 2x plus 4. So go up to 4, we go up 2 to the right 1, or down 2 to the left 1. And we see, oh, there's where they intersect. So a single answer at negative 3, negative 2. So in these last two, the equations could be really weird looking, okay, but you still treat it the same way. 15 is basically already solved, so a starting point of negative 2, slope of negative 5 over 2, so down 5 over 2, or up 5 to the left 2. Okay, then this one I could add a 2y, giving me x plus 8 equals 2y. Divide everything by 2. We get 1/2 x plus 4 equals y. So go up to positive 4, slope of 1 over 2, up 1 to the right 2, or down 1 to the left 2. see where they intersect. So my answer is negative 2, 3. Alright, now let's do one more and then give you some time to work on it, okay? So 16, I could rewrite that in this format, just swap sides with them, but we're going to have to divide by negative 3. So we get y equals positive 3x minus 2. Start at negative 2, then I go up 3 to the right 1, or down 3 to the left 1. And then this one, you just got to divide everything by a negative 1, giving us positive y equals positive 3x minus 2. Oh, same exact line. So I know that there are infinitely many solutions. And you can just write many solutions. So every one of these is an answer. Alright, now you've got the last 4 problems. So take a look at these ones and give yourself some time so that you can work on these ones. So pause the video now and get to work on them. Alright, you should have some time to work on these ones, so let's see what we'd come up with. So we divide by negative 1 on this one, giving us y equals positive 3 plus 5/3 x. So I go up to positive 3. Then we're going to go up 5 to the right 3, about there, or down 5 to the left 3. Okay, then the second problem. Subtract a 12, giving us 3y equals 2x minus 12. Divide by 3. We get y equals 2x over 3 minus 4. Start at 4. Then we go up 2 to the right 3. Or down 2 to the left 3. Okay, now it looks like we're running out of space here, aren't we? Okay, so if we went down 5, and then the left 3 put us right there. Okay. So sometimes you can run into this problem. Now we'd go down 2. This would be negative 7. And I realized my mistake. Crap. That's no good. That should have been a minus because we divided by a negative 1, so you got to pay attention to mistakes like that. So this one was correct, up 2 to the right 3. Our problem was this guy. It would have been 3, but we go down 5 to the right 3. Oh, that's much easier, isn't it? Oh, that was a horrible draw. Okay, so we end up with 3, negative 2. Much easier, okay? Now, if we look at the last 3, we're dealing with some exponents, which can be troublesome. So we start by the first numbers are y-intercept. Then every time we go to the right one, we're going to double it. So to the right one, I'd go 8. To the right one, we'd go 16. If we go to the left, we're going to cut it by half, because the opposite of timesing by 2 is dividing by 2. So the left one, we cut that in half. To the left one, we cut it in half. And so on, until we hit that asymptote at the x-axis, so it's going to look something like that. Okay, then we go plus 6, and we're going to go up 5 to the right 2. So it could be up there somewhere, or down 5 to the left 2. So it looks like we're going to possibly cross twice. One of them we can see pretty easily, negative 2, 1. Because they're not linear, the same 3 rules don't really apply. But it could be tough to figure out where the other one is. This is where using technology is helpful, because we find out that at 1.15, 8.874 is where the second one is. So we can see from this Desmos that I used, which we've used in class before, I graph it. The red one is the exponential. Then the linear is blue. See, we got one of them right, -2, 1. And then our other one. So there was 2 options here. Okay, so let's try the last 2 now. So we graph 3 to the x, so it's y-intercept of 1. It's like 1 times 3. Then we go to the right, we triple. Go to the right, we triple. To the left, into a third. So we end up with this. Okay, then for this, we start at -4. We go up 3, to the right 4. Okay, and because the exponential is growing so much quicker, these are never going to touch, so this is another no solution one. Okay, so then the last one, 2 to the x, that's like 1 times 2 to the x. So start out at 1, then we double it to 2, 4, 8, cut it in half. It looks like this. Okay, then our other one is another exponential. Okay, now this one's a lot more difficult because it's adding 1, so it shifts everything up by 1. So its y-intercept normally would be 1. Okay, so normally its y-intercept would be here, but we shifted it up 1. This -1 over here shifts it to the right one. So it actually crosses right there. And then as we go to the right one, it cuts it in half, and in half, and in half. We go to the left, it doubles it. So it would look like this. And so the answer is actually there at 1, 2. And they only cross once. And we can see here if we graphed it, here's our yellow line. There's our purple line. We can see that, yeah, 1, 2, they intersect. All right, there we go.